Hi, welcome back to engineeringtalks.com. Have you heard of shear force and bending moment diagrams? In this video, as well as in the upcoming 3 to 4 videos, we'll be dealing with the topic shear force and bending moment diagrams. So, happy learning and don't forget to like and share the video and subscribe the channel.
Shear force and bending moment diagrams of beams. First, let's go through the topic shear force. Shear force is the algebraic sum of the vertical forces acting on the beam either to the right or left of the section. I'll explain this. Here we have a simply supported beam. In the next video, I'll explain the different types of beams and the different types of loadings, okay? This is a simply supported beam. Suppose we apply an external load of 1000 Newton at the center of this beam. Then we'll have reactions at the supports, right? These reactions Ra and Rb will be equal to 500 Newton each in order to support or resist this externally applied load of 1000 Newton. Now consider a section XX which splits this beam into two portions. On the left side of this section, we have just one reaction force which is equal to 500 Newton and it's acting upwards. So here we do not have to take any algebraic sum of the vertical forces since we have only one vertical force here. Now on the right hand side of the section, we have two vertical forces. One is the reaction force and the other is the load, that is the externally applied load. So the algebraic sum of these two forces will be equal to 1000 Newton downwards minus 500 Newton upwards, and the resultant will be 500 Newton downwards. So on the right hand side of this section, we have 500 Newton force acting downwards. Now shear force is the algebraic sum of the vertical forces acting on the beam either to the right or left of the section. Now consider the left side of the section. We have 500 Newton. Okay, and consider the right hand side of the section. Here also we have 500 Newton. The only difference is that on the left side it's acting upwards and on the right side it's acting in the downward direction. So in order to find out the value of the shear force at this section, we just need to consider any one side of the section. That is, you can consider left side or right side and we can obtain the value of shear force. So here on the left side we have 500 Newton. On the right side also we have 500 Newton. So you just need to consider any one side in order to find out the value of shear force. And the value of shear force will be equal to the algebraic sum of the vertical forces present on that side of the section. On the left side of the section, we have a force of 500 Newton which is pushing this portion of the beam in the upward direction, and on the right side of the section we have the resultant force of 500 Newton which is pushing this portion of the beam in the downward direction. As a result of which this portion of the beam moves in the upward direction and this portion of the beam moves in the downward direction like this. And this is known as the shearing action in beams. Here the beam will be cut into two parts. And the forces which bring about the shearing action in beams are known as the shear forces or the shearing forces. Therefore, the shear forces are the unaligned forces pushing one part of the body in one specific direction and the other part in the opposite direction. And the shear forces always act in a direction parallel to the cross-sectional area. This is the cross-sectional area of the beam. And the shear forces, which are the vertical forces, always act in a direction parallel to the cross-sectional area of the beam and perpendicular to the axis of the beam. Axis of the beam will also be horizontal. And these vertical forces will always be perpendicular to the axis of the beam and parallel to the cross-sectional area of the beam. I already explained how we can obtain the value of shear force. Now let's move into sign convention. Shear force will be considered positive if the resultant of the forces to the left of the section is upwards or to the right of the section is downwards. This is a section. Now on the left side of the section, we have one reaction force and this is the resultant force. And this reaction force is equal to 500 Newton and this is acting in the upward direction. Therefore, on the left side of the section, we have the resultant force acting in the upward direction. Therefore, shear force is positive. Now, you can check the same on the right side also. On the right hand side of the section, we have one reaction force and one externally applied load. Now, the resultant of these two forces is 500 Newton which is acting in the downward direction. Therefore, on the right side of the section, we have the resultant force acting in the downward direction. Therefore, shear force is positive. Let's see what is meant by bending moment. Bending moment is the algebraic sum of the moments of all forces, that is, loads plus reactions acting to the right or left side of the section. See here, this is the section. Now we'll consider the left side alone, okay? Here we have a reaction force acting in the upward direction. This force has the tendency to rotate the beam like this. This is the clockwise direction. So this force has the tendency to rotate the beam in the clockwise direction. Bending moment is actually the reaction induced in the structural member. Here the structural member is B. So it is the reaction induced in the structural member as a result of the external force acting perpendicular to the member, causing the member to bend. Next is sign convention. The bending moment at a section will be positive if it tends to bend the beam in this manner, that is with convexity at the bottom and concavity at the top. Okay, such a bending moment is known as sagging moment. And the bending moment is said to be negative if it tends to bend the beam in this manner, that is with concavity at the bottom and convexity at the top. Such a moment is known as hogging moment. We saw that the shear force is positive when the resultant of all the forces on the left side of the section is acting upwards, or the resultant of all the forces on the right side of the section is acting downwards. So we have similar rules for bending moment as well. The bending moment is considered positive if the moment of all the forces and reactions on the left portion of the section is clockwise, or on the right portion of the section is anti-clockwise. So if we have the moment of forces and reactions on the left side of the section clockwise, or the moment of forces and reactions on the right side of the section anti-clockwise, then the bending moment will be positive. And if the moment of the forces and reactions on the left side of the section is anti-clockwise, or the moment of forces and reactions on the right side of the section is clockwise, then the bending moment will be negative. Consider this. Here we have the section XX at a distance of 1 meter from the end A. Now let's find out the value of bending moment at this section. On the left side of this section, we have only one reaction force. So, bending moment at this section due to this reaction force will be this force into perpendicular distance. So, this force is 500 Newton and the perpendicular distance is 1 meter. And this force has a tendency to rotate the beam in the clockwise direction, right? And we know that if the moment is in such a way that it has the tendency to rotate the beam in the clockwise direction on the left side of the section, that bending moment is considered as positive. So, the bending moment caused due to this reaction force will be positive, and the value of bending moment will be equal to 500 into 1, which is equal to 500 Newton meter clockwise. Now on the right side of the section, we have one reaction force and one load. Now this reaction force is equal to 500 Newton and the perpendicular distance between this reaction force and the section is 2 plus 1, which is equal to 3 meter. And this reaction force has the tendency to rotate the beam in the anti-clockwise direction. And we know that if the moment is in anti-clockwise direction on the right side of the section, that moment is considered as positive. So, this moment due to the force RB will be positive. So, the moment at the section XX due to RB will be 500 into perpendicular distance, that is 2 plus 1, that is 3. So, 500 into 3, which is equal to 1500 Newton meter anti-clockwise. So, 1500 Newton meter anti-clockwise. And the moment due to this load 1000 Newton will be 1000 into the perpendicular distance. So, perpendicular distance is 1 meter and this load has the tendency to rotate the beam in the clockwise direction. And we know that if the moment is in such a way that it tends to rotate the beam in the clockwise direction on the right side of the section, such a moment is considered as negative. So the moment due to this load is negative. Therefore, minus 1000 into 1, and that is clockwise direction. Therefore, 500 into 3 minus 1000 into 1, which is equal to 1500 minus 1000, which is equal to 500 Newton meter anti-clockwise. Okay. Now we have 500 Newton meter in the clockwise direction on the left side of the section and 500 Newton meter in the anti-clockwise direction on the right side of the section. Therefore, clockwise on the left side and anti-clockwise on the right side. Therefore, the bending moment is positive and the bending moment tends to bend the beam in such a way that the concavity occurs at the top and convexity occurs at the bottom, and the moment is known as the sagging moment. Therefore, the bending moment at this section is considered positive. So, what are shear force and bending moment diagrams? A shear force diagram is the one which shows the variation of shear force along the length of the beam. And some of its applications are, it helps to determine the principal stresses. Principal stresses are the normal stresses. It helps to determine the maximum shear force and its location, etc. And a bending moment is the one which shows the variation of bending moment along the length of the beam. And some of its applications are, it helps to determine the maximum bending moment and its location in the beam. It helps to locate the point of contraflexure. That is, the point of contraflexure is the point where the bending moment changes its sign. So, I'll explain all these things in the upcoming videos. Whenever we apply a load, it gets transmitted throughout the material. So, using these shear force and bending moment diagrams, one can analyze the type, size and material of the member so as to avoid the structural failure. Please do like and share the video and subscribe the channel. Thank you.